So chapter 3 and chapter 4 are filled with these types of problems, where you're going to have to try to maximize or minimize something, in this case, revenue. In your project for this chapter, if I remember correctly, you're maximizing the amount of protein someone ingests, depending on what supplements the person takes. But you have to do it under certain restrictions. Like, for instance, if there was an unlimited amount of wood and an unlimited amount of labor available, then it would only make sense that this shop only makes tables because they're going to sell for more money. But under these restrictions, is it feasible for them to make all these shops, all these tables, and with it, that chairs make a lot less money. At the same time, they use up less resources. So that's the point of the problem, is to figure out how many of each they should make. And the big assumption is everything's going to sell, because why make something if it's not going to sell? All right. And then to figure out how many of each they should make, and also how much money they'll make in the process. Anytime you don't know something in mathematics, you give it a name. Do we know how many they should make? What do you want to call it? X it is. So X will be the number of chairs. Do we know how many tables to make? Nope. Y will be the number of tables. That I love two different ways. I'm a winner. Okay. Let's write up some inequalities. The inequalities are based on your restrictions. Notice we have a restriction on what? Hours and wood. We don't have a restriction on price. We want to sell as many as we want. So since the word wood appears first, I'm going to write that inequality first. So we're going to have a wood inequality first. You want to put your numbers together. So we're going to put all the wood numbers together. So a chair uses 5 pieces of wood. We're selling or creating X chairs. How much wood do we need for the X chairs? 5X. So each chair needs 5 pieces of wood. We have X such chairs. So we have 5X pieces of wood just for the chairs. A table needs 11 pieces of wood. We have we have Y such tables. How much wood do we need for the tables? 11Y. So 5X plus 11Y is the expression that represents the total amount of wood being used. But notice it says there are at most 80 pieces. Well, at most means less than or equal to. Less than or equal to 80. So that's our wood inequality. And as you guys said, we also have another restriction on the amount of hours, labor hours. Now, writing the words wood and hours, that's up to you. I'm only doing that as a guide. You do it until you definitely get used to these. Each chair needs 9 hours of labor. We have X chairs, so how much hours of labor do we need for those X chairs? 9X plus, how about the tables? 17Y. And we have at most 240 hours. Very good. Can you sell a negative amount of chairs? Can you sell a negative amount of tables? No. So we need our non-negative inequalities. X and Y are both greater than or equal to 0. Well, if we don't have those there, then we can have negative amounts of tables and chairs. Is that okay? Okay. Now notice the only numbers, and those relate to the revenue. If each chair sells for $60 and we have X of them, how much money do we make from the chairs alone? 60x. Plus, each table sells for 160. We have y of them, 160y. And this would be our revenue equation. Now, you can call this capital R for revenue. But typically for these problems, we use a generic letter, namely the letter Z. So you might see lowercase z equals this expression. But for this example, we can call it a capital R. And what are we trying to do to this revenue? We're trying to maximize it. So we're trying to maximize the revenue expression, which is 60x plus 160y, subject to the restriction we have on wood, the restriction we have on others, and also making sure we don't of chairs and table. So all that in English is all that in math right here. This is what is called a linear programming problem. If you want, because we're going to be writing that phrase about a lot, you can call it LPP, but you have to finish it off with it's your choice. If you don't get the reference, I'll play the song for you later. Very good.